In this video, we'll do questions based on the type of rational numbers, whether they are terminating or non-terminating but repeating. Now, let us see the first part. We have to check whether without actually dividing it, we'll check whether the decimal expansion of this first one will be a terminating or non-terminating. So for that, first of all, we have to prime factorize both the numerator and the denominator. So here we are having 29 over 2 cube into 5 square. Now 29 is already a prime number, so it cannot be prime factorized, so it is to be written as it is. And the denominator already is in the form of prime factorization, so 2 cube into 5 square. So it will have decimal, therefore given number will have terminating decimal expansion, will have terminating decimal expansion. Why? Already, as I have explained you in the earlier video, that whenever the denominator in the simplest form is having only the prime factorization of the prime numbers, the prime number 2 and 5, either 2 or 5 or both 2 and 5, in that case the decimal expansion will be always terminating. So what we can see it here in the prime factorization of the denominator, only the number 2 is there and the number 5 is there. Now let us do the next one. 21 by 1600. 21 by 1600. So here also we will do the prime factorization. 21 can be done as 7 into 3, and if the number is bigger, you can always do the prime you can always do it separately. So 1600 we can write as 1600 can be written as 2 raised to 4, that is 16 into 100, and 100 can be written as 25 into 4, that is 5 square into 2 square. So how we can write 1600? 16 into 100, so 16 is 2 raised to 4, 2 into 2 4, 4 to the 8, it is 16, and into 100 can be written as 25 into 4, that can be written as 5 square into 2 square. Remember that we have to write only the prime factorization, so 7 into 3 over combining the powers of 2 raised to 6 into 5 square. Now we can see it here that if any number is being cancelled, that you have to cancel it out. There are no common factors in the numerator and denominator, so this is the simplest form. Now in the denominator, what you can observe, there are only factors of 2 and 5. Therefore, given number will have terminating decimal expansion. If you want to write down the reason, you can write down because the denominator is of the form, because the denominator is of the form 2 raised to m into 5 raised to n, where m n are whole numbers. So this is the answer of second part. Now let us do the third part, that is 31 by 8. 31 by 8. How we can write it as 31 is a prime number, again 8 can be written as 2 cube. That is 31 by 2 cube. So here we can see that in the denominator there is only the prime number 2. Therefore it will be terminating. So given number will have terminating decimal expansion. decimal expansion. We'll have terminating decimal expansion. Again, it is not necessary that the denominator should have the number 5 also. Only what is the condition? The denominator should have the prime number 2 as one of its factor, or the prime number 5 as one of its factor, or both 2 and 5 should be there, and no other prime factor should be there other than 2 and 5. But here we are having only 2. Therefore, definitely 31 by 8 will be having terminating decimal expansion. Now, similarly, you can try the fourth one. What is the fourth part? 17 by 3125. So that you will try on your own. Let us see the fifth one. 77 by 100, 210. So fifth part will try 77 by 210. That can be done as 7 into 11, and 210 can be done as 7 into 3, that is 21, into 5 into 2. So this is what we have got. We'll do prime factors of 210, that is 7 into 3, 21 into 10, and 10 can be factorized as 5 into 2. Remember that there should be only prime numbers as the factors of the denominator. Now what is common in both? 7. Cancel out 7. Again I am repeating, whatever factors are coming common in both numerator and denominator, you have to cancel them, because the number has to be written in the simplest form, and then only the rule is to be applied. Now in the denominator, what we can see that we are having the number 3, we are having the number 5, we are having the number 2. 5 and 2 are there, but the number 3 is also there. So there is, as earlier I told you, that the denominator should have only prime factors of 2 and 5, and no other prime factor should be there. So therefore given number will have non-terminating but repeating decimal expansion, but repeating decimal expansion. Now let us do the next part of this one, that is 13 by 52. Sixth part. We will do the sixth part. 13 by 52. That can be done as 13 by 52 can be done as 13 into 4 or 13 into 2 square. Now whatever is common, that you cancel out 13 and 13. So we get 1 by 2 square. So therefore here what is the number? Prime factor is only 2. Therefore it will be terminating decimal expansion. Therefore given number has terminating decimal expansion. Why? Because the denominator is having only the prime factor 2. Again I am repeating that denominator should have either 2 or 5 or both 2 and 5 as its prime factors.